ONPAR is an NGSS-aligned, multidimensional formative assessment system for middle school science. We have more than 75 tasks in full-length, mini, and paper versions, and the digital tasks are all automatically scored with rich, actionable feedback for both students and teachers. They're also universally designed to reduce the reading load to promote equity in your classroom assessment. Now we're going to take you through part of one of our chemical reactions tasks. The students can see the zinc metal and hydrochloric acid interacting. It's starting to form a gas, and I'm going to watch it fill this balloon, and then it'll be identified as having formed hydrogen gas and zinc chloride. Now we ask students to build a model of the investigation. I already did the side on the left, so you can see a student kind of bringing over these hydrogen atoms to show that they understand the H2 on the bottom means they need two hydrogens forming a molecule. This student is also showing their understanding of the conservation of matter because they put 4 hydrogens on the left, and so they also put 4 hydrogens on the right. Finally, they were able to understand that that meant we would have 2 molecules of these H2, which gives us a 2 coefficient at the bottom. Finally, we give students a data table and ask them to determine if they have evidence for a chemical reaction. On this slide, I want to highlight some of the language supports built into the ONPAR program. You can see as my mouse goes over these hyperlinked words and phrases, parts of the table are being highlighted or images pop up in the corner. And this provides support for any non-assessed academic vocabulary in the task. We also like this sentence stem framework for helping students build their discourse skills without lowering the scientific rigor being asked. If you notice in the corner, this says it's screen 8 out of 11. So this was just one part of a larger chemical reactions task. When students finish the whole thing, this individualized score report automatically pops up. The student report is organized into 3 tabs. This first one offers students feedback on each individual screen they just answered. We give them a progress bar to help them understand how thoroughly they answered each question. So they might first notice that screen 4 looked great, outstanding thinking. Screen 8, though, not so hot. So a student could click that screen 8 icon and review their answer for the screen, and then they can read the focus question. It tells them that the evidence they describe matches the data, but their claim about the investigation isn't accurate. How can you use data to determine if a chemical reaction has occurred? Our goal in writing these focus questions is to help build some student agency and ownership over their own learning. The middle tab is titled Watch Big Idea Videos, but you as an educator might recognize the 3 dimensions of NGSS. On this screen, we're pulling themes from across multiple screens to give students feedback on how well they did across the science ideas, the science and engineering practices, and the cross-cutting concepts present in this task. We still use a progress-based approach, and then give students more information and more detail about how well they did. The scientific idea present in this task is that substances react chemically in characteristic ways. And we tell this student that they may need to work on their understanding of how to identify when a chemical reaction has taken place. Students can look at the relevant screen or click that green video icon to watch a short video just explaining, well, how do you know when a chemical reaction has taken place? The idea is, again, to build some student agency and ownership. Can giving them just a little bit more information be what they need to really have that aha moment and have the content finally click? Finally, the Reflect and Plan tab is designed to build some student metacognition. We just give them a quick emoji reflection, then ask them to identify a strength and an area to improve. We offer a little bit of a fill-in-the-blank format to help students with their goal setting. They might write, to improve, I will talk to my teacher about how to know when a chemical reaction has taken place. Finally, at the very end, if students are still confused about any of these screens after getting all of this feedback, they can just check any of these boxes, which show up as a little flag on the teacher report. The teacher report is also organized into 3 tabs. Just like the students, the first tab gives us screen-by-screen results. But here for the teachers, we use color coding and bar graphs to help them quickly find patterns in the data so they can act on it. A teacher might notice that screen 4 looks pretty strong, but screen 8 looks kind of weak. This might be something a teacher will pull up and discuss before students have even left the room, or perhaps they'll design a little bit of reteaching for pretty much everyone the next day. We can also look horizontally to say, hey, student 7 did pretty well. I don't see that many questions, nothing read, so they got at least partial credit on everything. But student 4 is not so hot. I don't see any fully correct answers, and they also put a flag on every single screen. So as a teacher, I'm going to think about how can I pull student 4 in for an intervention, both to talk about the content and also to boost their confidence a little bit. The middle tab, just like for the students, gives information about the 3 dimensions. And again, here we're pulling data from across multiple screens to tell you how your students did on each of the cross-cutting concepts, practices, and science ideas present in this task. In the science ideas section, we even break it down into common incorrect ideas and common misunderstandings students might have. You can click View Students to pull up a student roster, and from there you can notice things like, hey, 88% of my students are struggling to use equations and 75% are struggling to identify a reaction. This again might be a place where I want to do a whole group intervention or think about how to build something like stations for a more differentiated approach. I can again look just at an individual student to say, hey, I want to follow up with this kid about showing atomic structure to make sure they understand, well, what's the difference between an atom and a molecule, and how do I model that? Finally, in the Reflections tab, we give you the information students put into their final tab of the report. What emoji did they choose? What strength and plan did they identify? Finally, there's also a space to write a message to your students. It can just be a quick way to give them some feedback after you spent some time looking at your own report. For more information, check out our website or send us an email. We'd love to talk more about how ONPAR can help you in your science classroom.